Yeah, a very good morning to one and all. I am Praveen and I am currently pursuing BTech third year at Aditya University. And today I want to make a demonstrate about my latest project, which is called object detection using YOLOv8. Yeah, without any delay, let's start about our project. Yeah, Let me tell you about YOLOv8. YOLO means an pre-trained ML model which was developed by Ultralytics, and V8 is its version. There are different versions like V8, N, S, M, L. N means nano version, S means small version, M means medium, L larger, X extra larger. Like this, there are different versions in YOLO, which was made by a company called Ultralytics. Yeah, the core of this task is to detect the real-time objects using this ML model and for the not ML model. Let me tell you somewhat clearly. Yeah, object detection is the core task that involves identifying and locating objects in the given picture. Unlike image classification, which assigns a single label to the image, here what will do is it will arrange a box for the each image. Each object in the image uploaded. Yeah, for each instance detected. Uh, as I said, YOLO is an you look only once. Its full form is a family of the state of the art and real-time object detection models for their exceptional speed and accuracy. And coming to the our backend services and front-end services, here what the process goes is the fast API backend. I have used the fast API for the backend service, which loads the ML model. Our ML model is nothing but pre-trained ML model YOLO V8 and express an endpoint for object detection. When we click the detect object, it will what it will makes is it exposes an endpoint. I mean, like at here the endpoint is detect and a simple Streamlit web UI. Here the web UI for the project I have used is Streamlit. As you know, Streamlit is a popular Python web interface building framework, which is completely developed by, which is completely built using Python. And also to interact with the API, I have used the Streamlit. And the entire application is Dockerized, which is a production ready standard. So without any delay, let's start the demonstration. The practical purpose. Uh, Let me start by running by Compose. Docker Compose Up. Here, what it will do is it will start the containers. I said that this application is completely Dockerized. Yeah, and I think you have got a clarity about what is the use of YOLO, real-time object detection within an image. Uh, Let me explain the real-world examples of this YOLO V8 and object detection. When we are using, like example is real-world examples are, yeah, autonomous driving. Have you saw that Tesla uses the autonomous vehicle driving, which means the car itself sees the objects and based on that it will take the decision and also medical imaging analysis. It's like that. There are many applications we can say. Yeah, the container is running. Why? And let me tell you why the tech stack I used is Fast API. Here, the Fast API is modern and which will be very fast for the API building such APIs due to its speed, and also you can see its documentation clearly by OpenSwagger or OpenAPI documentation. Yeah, and the containers are running. Localhost. And the port number I have used for this project YOLO8 object detection is 8501. Yeah. Here threshold, confidence threshold. The default value I set is 0.25. Uh, Browsers, pictures. For example, I am sharing an image with full of ingredients, I mean, or items, food items. I have uploaded. When I click detect objects, it will, yeah, detection completed, found 10 objects. Yeah, you can see here what are the items present in this, like a hot dog, 70% confidence. I mean, confidence means the present of accuracy. As I mentioned earlier, unlike image classification, here YOLOv8 what it does is it gives a box for each object. I mean, for each instance. See here, bounding box for hot dog is 70% and the values of it, apple, broccoli, carrot, like all the images I have mentioned. Let's see what happens when I increase confidence threshold to 0.50. Yeah, here you can see the confidence when increases, the number of detections has been decreased. I'll also tell you why it's happening. Yeah, after analyzing the image, I mean detecting the objects present in the image, it what it will do is in the output folder. I'll show you it. Last annotated JPC. Yeah, I already said that it will assign a box for each instance in the image. Here you can see what are the items present in there and their corresponding values. And all the source code I have been submitted in the GitHub. You can check it once. Yeah, the problem which I faced while developing this application is YOLOv8. While the model is very large and it makes nearly 10 plus 10 to 20 minutes for installing through Docker. Uh, I saw that why it's happening, but I realized that PyTorch was really nearly about 2 GB plus. So instead of that, I have shifted to CPU only PyTorch. And what I did is instead of running pip, pip install requirements.txt in the Docker file, uh, I have changed that to each and every tool that need to be dependencies, not tool. What are the dependencies needed to be installed by each and one line? Instead of unlike run pip install minus catch node and or requirements.txt, I have changed it to this version. uh, Installing each dependency individually, and after that the output will be stored as the last annotated image in this output folder. Mm, uh, yeah, let us also see the API endpoint response. JSON. Yeah, the detection for the each label and along with that the score. And the box we have seen the number of values, those are the instance of values of it. Yeah, that's it. You can check the source code in the GitHub, or you can visit my account, Satyanaga Praveen. There you can see real-time object and web app with the YOLO V8. Yeah, 4 GB of RAM is minimum required. I forgot to mention internet connection. Mm. And the port numbers I have used for the API 8000 and UI port 8501. And the model path which is downloaded by the from GitHub repo sent by Ultralytics company. Yeah, all the things I have shown here. uh, the API endpoint responses for object detection. Let's check the practical in this video demonstration of each API endpoint help. Yeah, the health of the container is status okay. I mean 200 code okay. Next, object detection. This is the structure of the project. Here API means our fast API application, and Docker file need to be, what are the dependencies we have to install. All these things are set up in this Docker file. And the models in the folder we have downloaded the YOLOv8 and nano version. Don't forget that model section I have described it here also. Yes. Thank you. Have a good day.